tracks are an indispensable part of train operations, as they are responsible for guiding the train along the ground. Therefore, train tracks facilitate the efficient transportation of goods and people over short and long distances. Not only are trains among the fastest modes of land transport, but they are very safe. They are less vulnerable to disruption due to poor weather conditions and are less likely to suffer accidents or mishaps than other types of land transport. They have also been great enablers of economic progress. Flat bottom rails. The flat bottom rail is the most commonly used rail type worldwide. They were originally conceived in the USA, although there was a delay in production due to a lack of steel mills at the time. They have a wide base and a head which is narrower than the base. Flanged T-rail is the name used for a flat bottom rail in the USA, and Vignoles rail is popularly used in the UK in reference to Charles Vignoles, who introduced this rail type there. They were first inserted in the London and Croydon Railway, and after it was recognized that they were much quieter than their predecessors, their popularity began to spread worldwide. Bullhead rails. Bullhead rails used to be the most commonly used rail type in Britain. From the mid-19th century until the mid-20th century, it was standard. Bullhead rails were a development of double-headed rails but lacked the symmetrical profile of the double-headed rail. This had the consequence that it could not be flipped over to use the foot as the head, meaning it had a short lifespan and was therefore an expensive track-laying method. This type of rail has been almost completely eliminated from the British rail network, except for some smaller branches. It has been replaced by flat-bottom rails. Conductor rails, also known as third rails, provide electrical power to trains or locomotives through a rigid conductor which is placed in between or alongside the rails of train tracks. They are usually completely or almost completely segregated from the outside environment due to safety concerns with high voltages running through them. Conductor rails are used throughout the world, but in some countries, such as Japan and South Korea, they are being phased out due to a preference for overhead wiring in their public transportation systems. So, how do train rails work? Tracks are made of two parallel steel rails, laid at a set distance apart. This is called a gauge. The standard distance between rails is 4 feet 8.5 in, and are connected by railroad ties or sleepers, as they are known in Europe. These are generally made of wood or concrete. The rails, in turn, are fastened to the ties. Underneath the train rail is the ballast, which provides a cushioning made of sand or concrete. The tracks are often raised above the ground in order to provide drainage for water removal. Steel is easily bent into shape, permitting tracks to be curved. Rails may also have switches, which allow trains to be moved from one track to another. Finally, signals along the tracks permit train officers to stay aware of changing conditions further along the track. How to transport train rails safely. Transporting train rails can be challenging, and safety is of the utmost importance. Cranes are used for lifting and laying the extremely heavy materials involved in laying train rails. These cranes transport older rails into storage and bring new ones into the working space. Finally, they feed the rails into a machine which lays them upon the ballast and lays them according to required spacing. In order to transport train rails safely, it is necessary to use a full equipped crane. A safe, functional, and modern rail clamp to facilitate the safe transportation of train rails, which operates in conjunction with cranes, is the new E-Track Rail Lifting Clamp. E-Track Rail Lifting Clamp. This new rail lifting system is an innovative way to transport train rails safely and securely. The new E-Track Rail Lifting Clamp orients and positions itself directly onto the desired rail. After it has been correctly positioned, the crane descends and is able to safely retract the targeted rail. The safety of the E-track rail lifting clamp is maximized by the use of an LED status indicator, which shows the rail lifting clamp's status at all times and is visible from the operator's position. It also features an auto-close mode, which uses a sensor to detect when the device has made contact with the surface of the rail. Train tracks are vital for guiding trains and ensuring efficient transportation of goods and people. They are integral to the infrastructure that supports economic growth by facilitating trade and reducing transportation costs. Over time, various rail types, like flat-bottom rails, bullhead rails, and conductor rails, have evolved to meet different needs, showcasing the importance of innovation in engineering. Additionally, the safety and reliability of trains, less prone to weather disruptions and accidents, highlight the significance of investing in robust transport systems. Modern technologies, such as the E-track rail lifting clamp, enhance operational safety and efficiency, further supporting the development of transportation infrastructure.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.